Welcome back for the fourth video in the series explaining Oracle VM networking with VLANs. We explored the fictional business systems in the last video. Now, the business systems will drive the design of the Oracle VM networking infrastructure. So in this video, we will translate the network requirements from the business systems into a high-level plan for our Oracle VM network infrastructure. So, before we go on, a little housekeeping. These videos pertain only to Oracle VM 3.1 and 3.2. I also assume that you've read the Oracle VM User's Guide about networking and understand the basics of networking. And I assume that you've read a couple of the white papers that I published on Oracle Technology Network about networking. Now, these are not best practices. That's not the goal of these videos. The goal of these videos is really to show you suggestions about process, not specific architecture for you. So they're only examples of how you might put something together. You need to add the thinking and creativity. So if I suggest something here that's not in your environment, then don't do it. Likewise, if I don't suggest something here that is in your environment, then you need to add it in. So in order to understand what we're trying to design, we need to understand the business systems that we saw in the last video. So we'll just do a quick review of the business systems before moving on. As you can see, this is basically the last slide we saw in the last video. We have two types of business systems: internal private cloud applications like BAM and HR, plus external facing cloud applications such as CRM and SCM. These business systems will be hosted on two different server pools. Server Pool 1 will be used as the platform for our data stores and middleware, and Server Pool 2 will be used as the platform for our application servers. That means each of our server pools will require slightly different network infrastructure, which are dictated by the way we construct our VLAN groups. Now, we'll talk about VLAN groups in much more detail later on. So continuing on, Server Pool 1 will have two different network profiles for Oracle VM guests. The virtual machines hosting databases will require three NetFront interfaces, and that's ETH0 for the internal facing network, ETH1 for the NFS storage, and ETH2 for the private rack traffic such as Cache Fusion and the CRS Heartbeat. Now, the virtual machines hosting middleware will only require two NetFront interfaces. They need ETH0 for the internal facing network and ETH1 for the NFS, and there's no requirement for the private rack channel in here, so that's why we only have two interfaces. Okay, now Server Pool 2 will also have two different network profiles for the Oracle VM guests it's hosting. The virtual machines hosting private cloud application servers will only need two NetFront interfaces, ETH0 for the internal facing network and ETH1 for the NFS. Now, the virtual machines hosting public cloud applications will require three NetFront interfaces, and those are ETH0 for the internal facing network, ETH1 for the NFS storage, and ETH2 for access to the applications portals from the external public facing network. Now, once we understand what will be required of the network infrastructure at a high level, we can begin to translate the requirements into the network infrastructure plan for our Oracle VM platform. Let's begin with the Oracle VM platform that we'll be using throughout this video series. Our platform begins with Oracle VM Manager installed on a server or virtual machine running Oracle Linux 6. In our case, the Oracle VM Manager is installed on a virtual machine running Oracle Linux 6. Server Pool 1 will host Oracle VM guests running data stores and middleware. All I have is some pretty old equipment, but it will do for our purposes. So we will build a 3-node server pool with Dell 2850s. We will present the pool FS and storage repository for Server Pool 1 using iSCSI. Now, Server Pool 2 will be created with two X4170s and will host our internal facing private cloud application servers as well as our external facing public cloud application servers. And we'll present the pool FS and storage repository for Pool 2 using NFS. Now that we have an idea of what our deployment architecture is going to look like, we can begin discussing the network infrastructure. So let's talk about the network infrastructure we need just to manage the Oracle VM servers and server pools, our management infrastructure. The manager will need to have a single internal facing network on ETH0. That's all the manager really needs. It doesn't need access to any of the NFS, iSCSI, or fiber storage networks that the Oracle VM servers will need. So the manager does not need access to anything related to storage on the Oracle VM servers or guests. So ETH0 is used by the manager to communicate to the Oracle VM master server. This is the server management channel on VLAN 200. Now I show ETH1 on VLAN 202 only as an option for NFS. This is because I normally make the Oracle VM manager or management server pull double duty to act as an HTTP server where I can stage downloaded templates for importing into Oracle VM, or as the internal YUM repo we require for the Oracle VM Update Manager, or whatever else I can think of for the management server. But other than my extra use for the server or VM running the Oracle VM Manager, there is no need for any network connection other than the management network on ETH0. The Oracle VM servers in Pool 2 will be configured with 3 bonded interfaces. I have divided the network loads for each of the 3 different Oracle VM management-oriented network channels across Bond 0, 1, and 2. So Bond 0 VLAN 200 is used for server management traffic between the manager and the servers. The manager communicates with the Oracle VM agent on the master server using Bond 0 VLAN 200. Now, Bond 0 VLAN 911 is used for the cluster heartbeat traffic. Bond 1 VLAN 200 is used for the NFS and iSCSI traffic. I will use this network to present iSCSI LUNs for the Pool FS and repositories to the Oracle VM servers in Server Pool 1. And then I'll also use the same VLAN for the Pool FS to present the Pool FS and storage repositories over NFS for the servers in Pool 2. And then Bond 2 VLAN 901 is used for our live migrate. The Oracle VM servers in Server Pool 1 will have the same exact network devices as Server Pool 2. Now keep in mind that everything on this slide pertains only to the Oracle VM network infrastructure needed to manage the Oracle VM servers and server pools. I have not yet explained anything having to do with the guest operating systems running on the Oracle VM guests themselves. So let's take a look at the network requirements for the guest operating systems running on the virtual machines. On the left we see Server Pool 1. Pool 1 will host the virtual machines running databases and middleware for all 4 business systems. The databases are all multi-instance databases running in rack clusters. On the right we see Pool 2. Pool 2 will host the virtual machines running application servers for all 4 business systems. The BAM and HR application servers are on the internal network only, so they only need 2 NetFront interfaces, ETH0 and ETH1. ETH0 on VLAN 442 is used for the internal facing network traffic like application communication between servers and middleware, as well as access to the guest operating systems by the application and support admins. Now ETH1 is used for NFS traffic to present application binaries and administrative tools like maintenance scripts to the guest operating systems. Now notice that the VLAN 202 here on DOM-U or the guest is the same exact VLAN 202 we're using for DOM0 or the Oracle VM servers. So they're both being, our VLAN 202 is being used both at DOM0 and DOM-U to allow access to iSCSI and NFS traffic. Like the BAM and HR virtual machines, the CRM and SCM application servers will also have ETH0 and ETH1 for the same purpose. However, CRM and SCM guests will have an additional ETH2 NetFront interface that the other application servers don't have. ETH2 is used for the external facing network traffic for the public cloud. So ETH2 on the CRM virtual machines will use the subnet on VLAN 930 to access the extranet, while the SCM virtual machines will access the extranet using the subnet on VLAN 931. The virtual machines running on server pool 1 will have the same ETH0 and ETH1 interface using VLAN 442 and VLAN 202 as all the other virtual machines. So every virtual machine and all server pools have the same exact net front interfaces, with ETH0 as the internal facing front end and ETH1 to access the NFS storage. Now keep in mind that the internal facing network on ETH0 is using VLAN 442 for the virtual machines, while the internal facing network for the Oracle VM servers is using VLAN 200. Certainly not a requirement or a best practice. I'm just trying to illustrate the flexibility of VLANs. Now, the virtual machines running databases will have a third interface that the middleware guests do not. The database servers will also have an ETH2 that will be used for private rack network, which is dedicated to cache fusion and heartbeat traffic for the Oracle clusterware. Now, each rack cluster will have its own dedicated VLAN for the private rack traffic. ETH2 on the BAM guests will be on VLAN 902. ETH2 on the HR guests will be on VLAN 921. ETH2 on the CRM guests will be on VLAN 922. And ETH2 on the SCM guests will be on VLAN 923. Again, this is not a best practice, since in our case, it's all going across the same wire, so there's no performance gain for having a dedicated subnet for each rack cluster. It might be useful to divide the traffic like this for troubleshooting purposes, but I'm really just trying to show you possibilities. So that about wraps up our discussion on how to begin turning business system network requirements into a plan for an Oracle VM network infrastructure using VLANs. In our next video, we'll talk about how to diagram our VLAN usage.